all of this came about in 1964 thanks to Bill Sharp, a professor of finance at Stanford University, who in '64 published a paper describing this idea of the capital asset pricing model. What he said was the expected return of any asset you can possibly imagine is going to be given by the rate of return on a risk-free investment like T-bills, plus a risk premium, a sweetener, a reward, a bribe, if you will. And what is that bribe? That bribe is directly proportional to the bribe that you need to be paid to hold that portfolio of the most diversified assets in the world, the market portfolio. Whatever that extra return is that you need in order to hold the market portfolio, the rate of return that is required for your investment is going to be proportional. And the constant of proportionality is known as beta. It measures the association of your fluctuations of return for your investment with that of the market. If you move in tandem with the market, you will have to pay the same risk premium as the market in order to bribe investors to hold your investment. If, on the other hand, you have a completely counter-cyclical movement of the market, you have a beta of -1, you actually will be able to charge a premium for people to invest in your investment. And so this idea of a market risk premium, which is historically about 7%, most people think that going forward it's lower, but that market risk premium multiplied by the beta is how we make a risk adjustment. Okay? The beta, mathematically, is measured as the covariance between your asset and the market, that most diversified portfolio, divided by the variance of the market. That's how we measure it. And we can run a linear regression to estimate it. And it turns out that this idea sent shockwaves throughout the industry. It is the basis of mutual fund indexing, which is a multi-trillion-dollar business. In fact, Vanguard just hit a milestone recently. It just crossed the $4 trillion threshold, Vanguard. And so these ideas are real in the sense that they actually help investors diversify their risks. But the reason we're interested in them for the purposes of capital budgeting is it gives us a way of figuring out what investors need in terms of a bribe, a reward, a risk premium. Okay? So the risk decomposition that I was referring to before is based on the CAPM and the ex-ante version. Ex-ante simply means before the returns are realized, we have random variables. The return of your asset is equal to the risk-free rate plus this risk premium plus a random term epsilon. So if you take the expectation of this equation, you get this equation. Nothing mysterious about that. And what the CAPM allows us to do is to say that the risk of any investment is comprised of two pieces. One is a idiosyncratic piece. That piece you're not going to get rewarded for. So just forget about that piece. Don't bother even measuring it. What you're going to get rewarded for is the systematic piece, the part that you cannot get rid of because it's correlated with that most diversified of all portfolios. Only systematic risk contributes to the risk premium. And so this is the example that I use to make this plain to my students. I point out that here's an example of a very risky job, window washers in Manhattan skyscrapers. And you would think that because it's a high-risk job, you get paid a risk premium for washing windows on these skyscrapers. And sure enough, if you look at salaries, does anybody know what salary you would expect for a window washer for these Manhattan skyscrapers? What would you think a reasonable salary might be? $15,000 a year? Higher? All right, $20,000? $30,000? Now, you realize this is New York City, right? And there's like a lot of people in New York. Many of them don't have fancy degrees from fancy universities. They need jobs, and they're willing to work in all sorts of ways. Not all of them drive Uber cars. So what do you think? 30,000? 40,000? 50,000? So it turns out that there is a lot of risk, and this is a slide that actually shows just relatively recently, 2 window washers almost fell off their catwalk when one of the ropes actually slipped. They were trapped for a couple of hours and ultimately rescued, but it took a while. So this is serious business. Well, let me tell you what the salaries are. Turns out that here's a picture of those folks. So there's a website, New York high-rise window washer details for salaries in New York. Who knew that there'd be a website on this? But there is. And it turns out that for somebody with average experience, we're looking at about $47,689. For somebody starting out in the business, about $39,000, and for somebody with a lot of experience, $56,000. Now, those of you who are thinking about summer internships in New York, you probably know that it's actually pretty hard to find affordable housing in New York. But of course, there's always Queens, the Bronx, Staten Island, and so on. And so these numbers, they're probably surprising to you because they're very high. But risk-reward, right? That's the market clearing price given the risk. So the thought experiment that I usually ask my students is, imagine if there was a window washer that enjoyed tap dancing while they washed windows on these very narrow catwalks. I'm not talking about, very mild kind of dance. I'm talking about the Michael Flatley, Lord of the Dance kind of really serious dancing. You would think that that would be a lot more risky, and therefore, those kinds of window washers should get paid more, right? Why not? You're shaking your heads. Why not? They're taking more risk, more reward. It's not systematic risk in the sense that you don't have to be tap dancing while you're washing windows. That's not part of the job. If you want to do it, that's on you. You're welcome to do it. And therefore, you're not going to get paid extra for doing it. So the question from the pharmaceutical perspective is, do you need to be taking these risks? Are they systematic or are they idiosyncratic?